Welcome to A Level and AP Physics, a place where you can improve your understanding of physics with confidence. In the previous videos, we have discussed a lot about motion graphs. In today's lesson, I will teach you how to write an equation for a given motion graph. This is a great video on this topic. Watch this video carefully and improve your understanding. First of all, let's try to sketch the given situation. In this case, we have a ball that is thrown vertically upwards and its initial velocity is given that is equal to 20 meters per second. As it is projected upward, the ball will go up and finally it will reach a maximum height. Let's say this is the maximum height. At this point, velocity will be 0 and then ball will start accelerating downwards. Velocity 0, its speed will start increasing, simply I will say, but its acceleration at this point is also equal to g because force of gravity is still same. So it will start speeding up down, so it will again come back to the same point at this point. So as its initial velocity is equal to 20 meters per second and there is no air resistance, so when the ball will reach the ground again, just when it strikes the ground, its velocity v again will be equal to 20 meters per second, and this is according to law of conservation of energy. Again we have this ball, but this time we will just sketch in a little different way so we can study more about the motion of this ball. As it is given to us, its initial velocity is u and that is equal to 20 meters per second. When the ball will reach at this point, let's say this is any random point we just picked, and that is true for any point along this path. So at this point, the force acting on the ball is the gravity Fg, and the acceleration of this ball is down, a is equal to g, because there is no air resistance. And also we can say in this case a is equal to 10 meters per second. Ball when reach at this point its velocity is 0 but its acceleration is not 0. It is still equal to g, a is equal to g, and this is equal to 10 meters per second, and its direction is downwards because a and f, according to Newton's second law, F is equal to m. F and A, they always have same direction. This is very important point. We need to be quite clear about this. Now let's try to study at this point when the ball is moving down, its velocity is down, we can say v is down. And acceleration is again still it is down, and a is equal to g. So what is difference between, if you draw a line here, when the ball is rising its speed is decreasing, when ball is falling its speed is increasing, but its acceleration is same at any given point. When the ball will reach the ground, its velocity v will be equal to 20 meters per second, but its direction is opposite, and this is according to law of conservation of energy. Now we will discuss how to write an equation for the given graph, means general and specific equation, how we can write if a graph is given to us. As you can see here on the right side, we have displacement time graph and we have velocity time graph, and acceleration time graph is also given to us. Time is on x-axis and time is in seconds. We need to understand what is gradient. We need just some key concepts and then we can write the equation. For example, we need to understand what is gradient of velocity time graph, mean gradient of vt graph. This is simply equal to a, means is equal to acceleration. We we also need to understand area under VT graph. Area under VT, that is equal to displacement. So we can say that area is equal to displacement. First of all, let's try to write down equation for AT graph. As we can see here, A is on the y-axis and T is on x-axis. If we look at this one carefully, we can also see that A is not depending on time. It simply means that A is constant. So it is independent of time. It is not changing with time. So simply we can say A is equal to constant. For this situation, we can say A is equal to minus 10. Now let's move on to VT graph. As you can see, the velocity is on y-axis and time is on x-axis. As this is a straight line, we can compare with this one straight line equation. Y is equal to mx plus c. In this case, y on y-axis we have velocity, so we can replace y with v, and the slope of this line, the gradient of this one, we have already discussed, that is equal to acceleration. So we can write a, and on x-axis the quantity given is time, so we can replace x with time, and c means the y-intercept, that is equal to u. So this is how we can write the general equation. So we can also write the equation for this given situation, means the velocity we can find at any given time, the value of v. A in this case is equal to minus 10 time, this is t, and the u for this case is given, that is equal to 20. So this is equation for this given situation. So this is how we can write. Now let's try to understand more about this velocity time graph. As we have discussed before, the area under velocity time graph, this is equal to displacement, and time here is 1 second, 2 seconds, 3 seconds, and time here is 4 seconds. After 1 second, if we need to find the velocity after at t is equal to 1, so the velocity will be equal to 10. As you can see, just replace t with 1 and you will get the v is equal to 10. So what I'm saying, let me just write down here. So this is minus 10 and we have time after 1 second, and here is 20. So our answer is here, 10 meters per second. So we can say the velocity after 1 second is equal to 10 meters per second. Velocity is equal to 10 meters per second and time is 1 second. So if we find this area, we will get this is 10 meters and this is 5. So it means after 1 second, the displacement covered by this ball is equal to 15 meters. Now if we move on to next one, we can also find this area, and this area is equal to displacement. So if we calculate this one, this is equal to 5. So at this point, displacement is 15, it covers 5 meters more. So at this point, the displacement or the maximum height, this is equal to 20 meters. Ball has reached maximum height now, so we can simply say this point is a peak point, means the maximum height. After this point, the velocity of the ball will change, means the velocity will increase, or simply we can say the speed will increase, but its direction will change. Now it will accelerate downwards. As we can see here, these two triangles, they are the same, the area is also same. So this area is equal to 5 meters, and if we look at this next area, this area is equal to this one, and this area is equal to 15 meters. So it simply means that after 1 second, the ball will reach at this point, and here the displacement of the ball will be equal to 15 meters, and then finally ball will reach at this point and displacement will be equal to 0. Or we can simply understand like this: the ball was projected from here, ball went up, and then ball simply came back to the same point. So that's the reason displacement is equal to 0. This is how we can write the general equation for displacement time graph. Simply we can say delta x is equal to ut plus 1/2 at square. Let me explain to you a little bit more about this one. If I simply write delta x is equal to ut, it simply means we can find displacement, and in this case we simply ignore gravity. If we simply ignore gravity, we will simply say delta x is equal to ut. But if we consider this whole equation, in this case we are considering effects of gravity. So how we can write equation for this given situation? We can simply replace u with its value, as the value of u is given, that is equal to 20, and a is equal to minus g. We can write down minus g. We can further simplify this one. As this is 20t, we can write down the value of g, and the g is equal to 10t square. In this case, we decided to choose upwards is positive. That's the reason the value of u is positive and a is minus 10. So this is our final equation for displacement time.